Hello everyone, welcome to this video where we are going to explore what we call the exponential functions. And in this type of function, the general function looks like this. Y equals to a number k multiplied by ax, a to the power of x, where x is the index of a positive integer. Okay, so in this case here, let's explore. There are two particular cases. The first case is where k, this number k, right, is a positive number. Okay, example will be like 2. Again, do take note that a is a number and it has to be a positive number, and x will then be at the index, okay, the power. So what happens? This is the general shape of this graph, where it will, from here, it will go. Do you realize what happens? As x increases, the y, yes, the y increases. So in this case here, we call this kind of function an increasing function. Okay. Second point to take note would be that it cuts the y-axis here at 0k. Okay. So this is actually what we call the y-intercept, and therefore the k is the y-intercept, and a to the power 0 is always equal to 1, and therefore when we substitute y equals to k times ax, right, and x is 0, right, this one actually leads us to k times 1. So therefore y is equals to k when x is equals to 0, which is where it is at the y-axis. Okay, and now do realize one observation is also that the graph lies entirely above the x-axis. Alright, that means all the y value is a positive y value. It also, the last point to take note is that at this particular point here that I highlighted here, do you realize it does not cut the x-axis? Rather, it gets very, very close to the x-axis when x is becoming smaller and smaller and smaller. So when x is a, so here when x gets very small. Okay, so these are the key observations for a exponential function where k is positive. Next, we are going to explore the case number 2 where k is negative. Hello everyone, welcome to this video where we are going to explore the case where k is negative. Yep, in this case here, negative 2. Okay, and so this will be how the graph looks like. The first observation will be that as x increases, you look at how the graph are moving. The y actually decreases. So this is a decreasing function. Okay, there's a typo there. Next observation will be at this point here where the y-intercept is k. So it cuts y-axis at k. At this point 0k, the y-intercept is k because a to the power of 0 is equals to 1. So y equals to k times a to the power of 0 is always equals to k lah. So the y-intercept is k, okay? Another observation is that the entire graph lies below the x-axis. And the last observation, which is consistent with the previous graph where k is positive, do notice that as we get very close to the x-axis, what happens to the y-x value? Okay, at this point here, probably I do want to, there's a typo, so I'm going to cover this up. So x, when x gets very small, okay? So that's the observation there. With that, we have come to the end of this exploration. Let's continue to move on as we explore more examples of this exponential graph. Hello everyone, welcome to this video where we are required to draw the graph of, let me just make it bigger. Y equals to negative 3 times 2 to the power of x from negative 3 to 3 for the x, okay? And in order to help us with this particular graph, we do need this table of values here. So this is our table of values. And let's start filling in, and this is my recommendation. Please use a calculator, and every time you key in a calculator, in this case here, for the very first value that I'm going to demonstrate here, which is here, where x is equals to negative 3, what will be my y? When I key into the calculator, I do make sure that I key in carefully as what I see here, okay? And from here, you should get negative 0.375, okay? And so the next number that I'm going to demonstrate before I just list out the number, this will be y equals to negative 3. Now is 2 to the power. Now my x is negative 2. So you should get negative 0.75. Okay. So for this particular value here, x will be negative 1, so meaning y equals to negative 3 times 2 to the power of negative 1, you should get negative 1.5. So as we continue, we will then be able to get all the rest of the values. So I'm going to just list out. You should get negative 3, negative 6, negative 12, and negative 24. And that's where we are now going to start to draw this graph on a graph paper. Yeah? So the first thing that caught my eye would then be the scale. For the x-axis is 1 cm to 1 unit, meaning usually we will have this as 5 small boxes. And for the y-axis is 2 cm to 5 units, meaning 2 cm will then be my 10 small boxes. So moving on to the graph paper now. And looking at the values that I have, all the y values are negative. So this is very important because this allows me to then simply draw the y-axis at the top, x-axis at the top, and 1 cm to 1 unit. Yeah, so that means I just need to make sure that I will have -3, -2, -1, 0. That's where the origin is. And this will be my x-axis. And now for my y-axis then, it will be somewhere here. And I just need to make sure that I will be able to hit -24. And it is 2 cm to 5 units. Yeah. So this will be my y. 2 cm means 10 boxes. That will be here. -5, -10, -15, -20, and -25. And let me just extend my line. Oops. Okay, and we are ready to go. Axis is done. Now is to plot all the points. Okay, so the first point will be -3. X is -3, y is -0.375. So moving on to here, -3 is there, -0.375. Each box is, this is a minor quick calculation. If I have 10 box, 5 units. So one box represents 0.5. And with this, -0.375 will be somewhere here. When x is -2, y is -0.75. So 0.75 will be in the middle here. Let's continue. -1.5 will be here. 0 and -3. So this will be -3 will be here. So as we continue to plot, 1 and -6, 2 and -12, it will be 11, 12, and the last one 3. Let me just make it smaller. 3 and -24, which is somewhere, which is here. All right. Next part of this graph will then be to connect the points together. Okay. So I'm going to use black color, purple color, so that it's easier. And I'm going to connect the points now. So let's start to connect the points. Okay, so I will have this connect, then slowly connect. Eventually they will make a slow turn, and eventually, yep. And last but not least, to complete this, we do need to write down the equation of this particular graph. Part A is done. As for part B, How can we then solve for this equation? 3 times 2 to the power of x equals to 10. So for part B, right, I'm going to do the working here. We just need to make sure that this side here must look something like our graph that we have just drawn. Negative 3 times 2 power x. But in this case, for part B, we started off with positive 3 times 2 to the power of x. This means that I'm going to multiply both sides by negative 1. So that I would have negative 3 bracket 2 power x. This will be equals to negative 10. And eventually, to use this graph, we already have drawn this graph here already. So the question now is, how then can we solve this equation? So do take note, this is actually the graph that we have just drawn, which is our y equals to negative 3 times 2 to the power of x. So essentially, right, what this question is asking is that what is the value of x when y equals to negative 10? And therefore, to solve this particular question, we just need to draw this line, and this happens to be a horizontal line. Here. Okay, so we are going to go back to this particular question. Go to y equals to, let me zoom in so that it's easier to draw. Negative 10. And I'm going to draw y equals to negative 10 here. And therefore, we will be able to get our answer. Our answer is here, the intersection point. So for this intersection point, then you will get 1.7, and therefore the answer to part B, x is equals to 1.7. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.